I'm on bed. We're gonna solve these equations using Jacobi method. First, we're gonna find x. So, 15x is equals to 18 minus 2y minus j. Then, 20y is equals to 19 minus 2x plus 3j. Then 25j is equals to 22 minus 3x plus 6y. Then we're gonna cancel out the 20 and the 25. 15, 20, then on the first iteration, we're gonna assume the x, the y, and the z to be 0. Then x is equals to 18 minus 2 times 0 equals 0 over 15. Since the variable is 0 and 2 times 0 equals 0, we're gonna cancel this. Equals to 18 over 15. The y is 19 over 20. It is 22 over 25. One point two is to 0.95 0.88, and this will be the value on the first iteration. Okay. I'm on bed. We're gonna solve these equations using Jacobi method. First, we're gonna find x. So 15x is equals to 18 minus 2y minus j. Then 20y is equals to 19 minus 2x plus 3j. Then 25j is equals to 22 minus 3x plus 6y. Then we're gonna cancel out the 20 and the 25. 15, 20, then on the first iteration, we're gonna assume the x, the y, and the z to be 0. Then x is equals to 18 minus 2 times 0 equals 0 over 15. Since the variable is 0 and 2 times 0 equals 0, we're gonna cancel this. Equals to 18 over 15. The y is 19 over 20. It is 22 over 25. are 1.2 is to 0.95 0.88, and this will be the value on the first iteration.
Second iteration, same method as the first iteration, but this time the value for x is 1.2, for y is 0.95, z is 0.88. So first we gotta substitute it for x. X is equals to 18 minus 2. Value for y is 0.95 minus 0.88 over 15. For y is 19 minus 2. Value for x is 1.2 plus 3z, 0.88 over 20. For z equals to 22 minus 3, 1.2 plus 6y, 0.95 over 25. Value for x is minus 2 1.01, and for y is 19 minus 2 divided by 1.2 plus 3, 0.88 over 20, that is 0.96. The last one is 22 minus 3, 1.2 plus 6 divided by 25 over 9 equals to 0.96.
Before we solve for the third iteration, we're going to do a table which is as we said earlier, we will assume that x, y, and z are all 0. So for the first iteration, all x, y, and z are all 0. For the second iteration, was x was equal to 1.2, y is equal to 0.95, and z is equal to 0.88.
But I am reading.
For the third iteration, x was equal to 1.01, y was equal to 0.96, and z is equal to 0.96. So for the fourth iteration, we will use the value of the third iteration for x, y, and z, which is 1.01, 0.96, and another 0.96. So for the fourth iteration, we will use the value of x, y, and z, which was solved from the last iteration, the third iteration, which is 1.01, 0.96, and another 0.96. We will use the first equation, which is 15x plus 2y plus z is equal to 18 for getting the value of the fourth iteration of x. So 15x plus 2y plus z is equal to 18, which makes x is equal to 18 minus 2y minus z all over 15. So the value of y from the third iteration is 0.96. So 18 minus 2 times the value of y from the previous iteration, which is 0.96, minus the value of z from the previous iteration, which is also 0.96, all over 15. So 18 minus twice the twice of y minus 0.96 all over 15, which is equal to 1.0 or equal to 1. So x is equal to 1. For the equation of y, we're going to use the second equation, which is 2x plus 20y minus 3z, which is equal to 19. That makes y, that makes y is equal to 19 minus 2x plus 3z all over 20. So for the fourth iteration of y, 19 minus 2 twice the previous value of x from the third iteration, which is 1.01 plus 3z all over 20, which is also equal to 1. And for the value of z, we will use the third equation, which is 3x, minus 6y plus 25z, which is equal to 22. So that makes z is equal to 22 minus 3x plus 6y all over 25. So that makes 22 minus 3 times the previous value of x, which is 1.01, plus 6 times the previous value of y, which is 0.96, all over 25. That makes z is equal to 1. So the value of x, y, and z is all equal to 1. So we're going to put the value of x, y, and z, the fourth iteration, to the table, which is 1 for y and 1 for z. In Jacobi method, once x, y, and z are all equal, that would be the last iteration, which is the fourth iteration. So x, y, and z are already equal, so we're going to start.